Ready to begin or just a random thumbs up? Okay.
We'll announce whenever it's time to start so you guys know exactly what's going on.
Perfect, thank you.
Sorry, I was letting one of Damien in. He emailed me, so I did give him a thumbs up on videos.
Oops. Hey, everybody.
Hi.
Okay, take it away, David.
Okay, perfect. I'm
Whoa,
going.
Sorry.
Oh, sorry.
David's gonna. No, it's okay. David's gonna introduce our reviewers first.
Yeah. So let me introduce the viewers, and Michelle will start. Thank you. We have two reviewers. One is August Black. Hey, August. August is a artist, engineer, and technologist. His current interests include technopolitics, functional reactive programming, alternative web architectures, AI machine learning, and building instruments for creative and technical expression. His past work focused on not live networked audio, often mixing FM radio and with user input through online software. August holds a doctorate in media arts and technology from the University of California, Santa Barbara, and he is a member of the web and engineering team at Cycling 74. Great, thanks August for doing this.
Yeah, thanks for having me, guys.
Yep, and good, great. Emmanuel Langumbai. Sorry if I butchered that. Thank you. Is an audio designer in Torrance, California. He has worked on projects like Torchlight 3, Devolver, Digital's E3 press conference, and is currently audio coordinator at Riot Games. So we are very lucky to have you guys do this with us. So without further ado, Michelle Glady is our first speaker. And you're still muted. There we go.
Yeah, I just unmuted myself. I wanted to make sure there was no random background noise. Just as a reference, I have my monitors over here, so you all are over here, and my presentation is over here. Additionally, if you have any questions, I wasn't able to get my sign language interpreters for this meeting, so if you could turn on your video before you speak, that would be really beneficial so that I can try and read your lips along with your question. Okay, and let me go ahead and share my screen. And okay, so for those of you that do or don't know, my name is Michelle Glady. I developed a haptic wearable audio transfer device, and so I wanted to create a wearable haptic jacket that allows for music to be translated into vibrations for the deaf and hard of hearing. Now, in a more general terms, I wanted to develop a tool to experience music through touch than rather through hearing with our ears. Really, sound is just another way of touch. It's touching your hair follicles inside of your ears. So I wanted to translate that so that your brain could experience the same experience that you get with music through your ears, but through touch on your body. Now, a lot of people ask me why. There was an article that was written about my entire experience in the Coloradan, but essentially in September of 2018, I actually went deaf completely for 6 months. And no one could explain why. But one of my favorite things to do was to sit in the car with my family members, blaring the music. And I couldn't tell how loud it was aside from the vibrations on the side of the car. And that was my favorite way to experience music when there was no other way for me to experience music. And so I then found out through David Shaw, he introduced me to Daniel Leithinger, and that is where from this influential precedent, I went to next. So going back to January of 2019, I actually had the opportunity to go to a private concert hosted by Mandy Harvey. If anybody knows her, she is an incredible deaf singer. She won America's Got Talent in 2017, and I was fortunate enough that a company called Not Impossible actually had this small concert where we were wearing these vests, these vibrating vests, that allowed us to experience her singing, but in a different form. So with that experience, I wanted to learn, how can I make this myself? How can I make this into something that's the equivalent of hearing people wearing headphones out in public? Because to be completely honest, I probably wouldn't wear this vest out in public. It would draw attention to me, unnecessary attention. So I wanted to create something that was fashionable, that was wearable out in public. That's when I got in contact with Daniel Leithinger, and he told me he had worked with haptics before and sound before, so we brought that all together and we decided to apply for a UROP grant. UROP stands for Undergraduates Research Opportunities Program, and I was fortunate enough that I received the maximum grant that they actually give. So that was a really incredible start to this whole process. So on a more technical side of things, I used Arduino, both hardware and software, but let's talk about the software first. Arduino is actually a language comprised of Java, C, and C++. And specifically, I actually used the Audio to Vibe library, and that was included with the haptic motor driver. And a haptic motor driver basically, took the translation of the code, put it into that driver, and that driver drove the vibrating motors. And so I tried my very best to code and parse out each of the frequencies so that I could have it be frequency specific on parts of the body, and hit quite a few brick walls with that. So I'm hoping to continue that progression here in the future. But as of right now, I use the library that I had available to me so that I could continue with the process of the jacket. Another thing that I used was the LilyPad Arduino, and I found it really interesting when I was looking into the LilyPad documentation and everything. That was actually developed by CU Boulder alumni, Dr. Leah Buickley, I believe. She developed it for wearables, so it was kind of cool that I'm using something that was developed by CU Boulder in my final project at CU Boulder. And then what I was talking about before with the haptic motor driver, on the right-hand side, you can see positive and negative, and that's actually where the vibrating motor attached to. And on the other side was where the Arduino code went into from the hardware, like the Red board or the LilyPad Arduino, went in, translated that into vibrations, and then you got that vibration experience, that haptic experience. This took many, many prototypes, and not all were successful, but enough to make this work. So initially, what I had to do was figure out, how did a haptic motor driver actually work? How could I get that translation of music into vibrations? And I started with just one, because as soon as you get one working, it's easier to get multiple working than starting with multiple and working down to one and troubleshooting. So I started with one, and then I worked my way up, and I got to three. Three worked pretty good. So I was like, okay, let's build the full scale model. And then we got up to 12 vibrating motors. Now this was off of the Arduino Uno board, which had significant enough power to power all 12 vibrating motors. Then I took all 12 of those and tried to put them on one LilyPad Arduino. For those of you that might have worked with a LilyPad Arduino before, let's just say things started smoking that weren't supposed to smoke. So that was when I learned my lesson that only 4 haptic motor drivers can actually be driven by one LilyPad Arduino. So that's when I got 3 LilyPad Arduinos and put 4 motors per Arduino, and then we had 12 in total. We were all good. I use Fritzing, which is an online application that allows you to map out the circuitry that you hope to accomplish, and that also helped me troubleshoot whether or not I could use one to power all 12, or if I needed to have multiple LilyPad Arduinos. Then I went on to develop the inner lining of the jacket. And I cut out fabric. This ended up not being the final inner lining of the jacket. It was not sufficient enough and, in my opinion, fashionable enough. So there was a couple of iterations, but this was one of the first iterations of that. Then I developed the full circuitry, all of the proto boards, and I attached them all together and made it run off of rechargeable batteries because I wanted to be something that you could wear while you were walking outside. So these are lithium-ion batteries that are rechargeable with a micro USB charger on the left-hand side. You can kind of see that. And then it was just attaching all of that wiring to the inner lining of the jacket. It may seem heavy, but it wasn't as heavy as it looks, I promise. Let's look at the final product. So for the final product, that's what it looks like. It's in the background right behind me right now. And no, that is not a jacket that that was sewn by me. I went to Target, many thrift stores, so that I could find a fashionable bomber jacket, which apparently is in fashion right now, the up-to-date cool thing to wear. So I bought one of those, and then on the inside, you can kind of see it in the left-hand side picture, is the black inner lining. And then the first red dot that you see on the left-hand picture is the battery compartment where all the batteries go on the inside of the jacket. And then on the right-hand side, you can see another red circle with the auxiliary cord so that you can plug that into your phone, you can plug it into whatever device you have to experience that music. This is me modeling the jacket. It fits just well, just great on me. I'm sure a lot of you know the song Eye of the Tiger. That happens to be my favorite song to go along with this because it has such a distinct bass line that you really can tell when it's working and when it's not. So I really love it. I have had fun with it, so much so to the point where it has broken a few times, more than a few times, but it is a great experience and I hope to continue to progress it. Before I say thank you to you all, I wanted to thank Daniel Leithinger. I know he's not necessarily on this call, but he was a huge help with the development of this jacket. Sean Kane and Zach Weaver helped me a lot with the hardware, software, and then also CU TAM, the entire professor program, everyone there, because without the skills that I learned from that program, I would not have been able to make this idea a reality. So thank you.
Great, thank you. And we'll take some questions from your reviewers. August or Emmanuel, who wants to go first?
Oh, thank you. I can go first if you want. Thank you for the presentation. Very ambitious project. Also very interesting. I like the fact that you talked about touching at a distance. It's one of my favorite texts on sound is by Armory Schaefer for the 1970s called The Acoustic Community, where he talks a lot about that idea. I also like that you mentioned Not Impossible Labs. Very cool product that they make. I had a pleasure of meeting them last autumn. I got the demo of the product that they make and talked to their engineers. And very, very cool thing what they're doing. Anyway, just kudos on that. I just wondered if you could tell a little bit more about how, like, I can't experience this thing from a distance. Like, how effective is it? I mean, it seems to me like you need to have it really tight on your body. That was one of the things that's really effective about the Not Impossible Labs thing, is that they put it in certain parts of your body. They really strap it on. They have someone kind of cue you up on what's happening. Yeah, I was wondering if you could just speak a little bit more about that.
Yeah, absolutely. So that was actually one of the prototypes that I went along and did was what fabric would work the best to develop the inner lining out of. And it actually came down to silk and satin are the two best that I found that actually transferred the vibrations through the fabric in a way that wasn't obstructive in other parts of the fabric. So that's actually the fabric that I used on the inner lining of my jacket. Bring it over here a little closer. But it is a satin fabric, and that even though it's not as tight as it could be to the individual's body, the vibrations are actually translated fairly well as long as you're not wearing a heavy wool sweater or something of that sort. But I did analyze different fabrics to figure out which one would be most efficient in translating that vibration.
Cool. I got a couple questions in terms of how it actually functions. I know you mentioned that you were looking at having it coded to certain frequencies. Can you kind of elaborate more on like what ended up happening in the final product?
Yeah, absolutely. So I was really looking into multiple different libraries to be able to figure out if it was possible to parse out the frequencies. And I tested out quite a few different things. I tried to do a write function, a read function, all of that for the input and output. And it worked terrifically until you hit pause on the music. When you hit pause on the music, everything blared. And no matter how hard I tried, I couldn't figure out a way, like even just doing like a write equals 0 so that it had nothing coming out, it would still have something coming out. So there was some disconnect there that I couldn't quite figure out in the time span that I had, of course. But moving forward, that would definitely be something I would want to be able to figure out.
Cool. Yeah, definitely. Like so that's something I was curious about because like how many different sensors did you kind of ended up happening or using, and where did they kind of end up on the body in the jacket itself?
Yeah. So that was part of my user testing was figuring out where the different frequencies would fit best on the body. So I actually have a vibrating motor that is right here on the individual's arm, and that I ended up deciding to be more of a mid to high frequency range. Low frequencies kind of became obstructive and it started shaking your hands and causing a little bit of a spasm. And then some places were a little too ticklish for individuals. So I tried to avoid those zones, but anywhere that was more ticklish, doing a lower vibration was worse because it was a very strong bass kind of hitting that ticklish spot, and it became uncomfortable. So it was a lot of research of figuring out where to put the motors. So I have one that's on the meteor part right before your armpit, is not actually a very ticklish place, but you do get to feel the vibrations. I have one on your shoulders on the back, but not on your shoulder blade, so it's not on a bone, but on the meteor part. And then I have 4 vibrating motors in your back, and then 1 on your tricep area on either side, and then right there. So 12
Nice.
in total. With the ideal product that I was trying to produce with parsing out the frequencies, they all would have had their own individual range they were accessing. But I wasn't quite able to reach exactly that.
Great, thank you. That's time. Thank you, Michelle.
Thank you.
We're gonna
Can I
do.
just make one more comment? Thank you, Michelle. I just want to say you should reach out to the people in Impossible Labs and maybe look for an internship or something. They're pretty awesome engineers, and you know they might really take hold of your story. Anyway, just a thought.
Yeah, thank you so much. Yeah, I'll definitely look into that. Thank you.
Great. Ari and Jack, you're up next.
I also want to remind all of the both the reviewers that you can fill out the spreadsheet too with any additional comments that you have as you're thinking about them, because we're going to be short on time for feedback. So.
Cool. Great. Thank you.
I'm going to share my screen now.
Go for it, Jack. Sweet.
Cool.
Cool.
So do we just go in error?
Are we good?
Yeah, we're unmuted. Sorry, go.
Okay.
We're unmuted.
Okay,
All right,
cool. How's it going, guys? My name is Ari Klepanov. This here is Jack Marty, and we're here to tell you about our Capstone project titled Musical Ears, which is a mobile app designed for you to expand your musical potential one note at a time. So what exactly is Musical Ears? Musical Ears is an auditory listening skills training app. Auditory listening skills are a musician's innate ability to listen to, understand, internalize music, whether that's notes, intervals, rhythm, things like that. And our app actually differs from others in the sense that it incorporates active ear training as opposed to passive ear training, which we'll talk about a little bit in the next slide. And of course, our app is designed for all musicians, whether you're a beginner, whether you're a master, whether you're a vocalist or an instrumentalist or somewhere in between all that, this app is designed for you.
Cool. So as Ari said, our app deals with active training. And so what active training is essentially just letting the user reproduce the note instead of just kind of select a random button that they think is correct. So this differs from passive training, which is what all other music apps today use. And passive training is essentially the app plays you a note, and it's the user's job to select what note they heard or what interval they think they heard. And so our app, the unique feature about it is that it uses active training. So the user is required to sing the note and reproduce it. And this is actually a more effective and motivating tool for training. In my research last semester, I came across this article by Christopher Sutton called Ear Training Essentials that he had this quote that says, in active training, you develop discipline, musical interpretation, and conscious skill. And yeah. So what already exists? So as you see, the app on the left is called Earpeggio. And this is just another music app that uses passive training. So it plays a note and the user has to select what they heard and what interval they heard. And then on the right is just a regular guitar tuner app that allows people to tune their guitars or tune their pianos. It uses a phone's microphone to hear a pitch and analyze the frequency and tell you what note it is. And so our app kind of combines both of these apps into one, and then that's how we get musical ears.
Cool. So as of right now, our app consists of two modules. The first one, the more simple one, is pitch matching. This one's pretty basic. The user is randomly assigned a note across 2.5 octaves or so, and it's their goal to match that target note in the least amount of time possible. As you'll see a little bit later, each module has a configuration screen. So the user is allowed to input how many notes they want to hit in a row before they complete the module. And you'll see in this module as well, there's a clock, a ticking clock component. So the goal is to hit that many notes, whether that's 10 notes, 20 notes, 50 notes, in the least amount of time possible to win. So as you'll see in the next slide here, we have a little bit of a demo showing how that works. Yeah, so this is a video. You'll see the app on the left. Starts with that configuration screen. Gonna hit start. It's gonna give us a random note. Then we go to the tone generator over here. We play it. And boom. So that's 1 point right there. We're gonna do another. D sharp. And there you go. So that's 2 points right there in pitch matching. Our next module is a little more complicated. This one's called interval training. This one asks that the user match the bass note and the interval note in order to score those points. Same deal with the clock. They specify before starting the module how many notes, or I guess how many intervals they want to match in the least amount of time possible. The notes that are assigned, the note is randomly assigned, the interval is randomly assigned. The interval can go above or below the note. And you'll match it in each of the distinct little sections right there. The one that's disabled is not listening at the moment, whereas the one that is disabled is listening. Maybe that'll make a little more sense when we show you the prototype on the next slide here. Same kind of format with the demo. We have the app on the left, the tone generator on the right. You get that interval. There you go. So that's 1 point right there. You can see the sections disabling and re-enabling. And there you go. So that's 2 points for interval training right there.
All right, so another feature of our app is that users have the ability to customize it, customize like their experience with each module. So both pitch matching and interval training come with a settings page that pops up before the user actually starts the module. And they have the option to select the number of questions they want to get right, or the note duration, which is just how long they have to sustain a note in order to get it correct. And also the ability to show the note names or not. And as you see in interval training, there is, they also have the ability to show the interval training or the interval note if they want to. And the show note names is an important concept because it's how we kind of encompass all musicians and design an app for all musicians. So whether you're a vocalist or an instrumentalist, you can make use of our app. So if you're a vocalist, ideally you would want the target note visible and with a longer note duration, whereas an instrumentalist would want the note hidden and a shorter note duration. And then this is just kind of, no matter what musician you are, you can find some use with our app here.
So here's a little bit of our trailer. Obviously, we're not going to show you the whole thing, but we'll show you a little bit of my roommate here using the app and how the whole point is to, at the end of the day, make some great music. So go ahead and play it. Oops.
Clicked on me. Got it.
This hit for 4. Okay.
Got it?
Yeah, I think I got it. Let's hit it. This hit that ice cold Michelle Pfeiffer, that white gold. This one for them hood girls, straight masterpieces, styling, wildin'.
Anyway,
So that was our trailer.
so that's enough of that, but yep.
And here's just some feedback we got from our friends that use their app. They said this app's really fun. The app's not just for singers, for all musicians, and they were really in love with our color scheme with the color purple.
Cool. So next steps for us, Jack and I both want to get our apps launched in the App Store. We developed this for iOS and Android, so we want to get them in both app stores. Currently, our launch date is set for the end of May, which will give us a couple more weeks to iron out any bugs that may have kind of stuck around, do a little bit more user testing, make sure that whatever we do get in the App Store is as complete of a product as possible. And it will be free, in case you were wondering. Post-grad as well, Jack and I discussed this. We both do want to keep working on this app. We do have some big plans for other modules in the future. Maybe a rhythm module to help the user train their innate ability to feel the rhythm of music, melody, where they'd have to match a couple different notes in random succession and be in tune to get your points. Harmony as well, which would be kind of the next step of that, where you'd have to match a melody but harmonize with it. So big plans as well. Eventually, we do want to have a paid premium version. Maybe that's where we'll stick all these other modules that we have hopes to be implementing at some point. But for right now, it's just the free, the basic version, and that will be in the App Store by the end of May here. So
There we are.
thank you so much for your time. Any questions?
Well, I'll pass this on to the reviewers. Thank you.
I guess you want to just default to going first, or
I was kind of hoping you'd step in first here, but I can if you want.
either way works.
All right. Thanks for the presentation, guys. Pretty cool app. I was wondering if you could just talk a little bit about the technology and the stack you used in developing it.
Yeah, I can take this one. So both of us, since we were developing natively for each of our platforms, there wasn't one framework, one library that we could use for both of us. I wound up using one called Tarsos DSB, whereas Jack used AudioKit, I believe. But basically, they have built into these libraries the FFT, the fast Fourier transform required to actually process the pitch into the respective notes. Our modules our libraries were slightly different in the sense that, like Jack would get amplitude, for example, but mine would be more accuracy, so we'd have to jump those hurdles as they came up. But at the end of the day, both of our libraries do use FFT to process that frequency and then let you know what note is being played.
And so, and as Ari mentioned, and we probably should have actually put this on our presentation, but So I developed through Xcode, iOS natively, and Ari developed through Android Studio. So we both developed our apps natively for both platforms.
Okay, one using Swift, the other using Java.
That's exactly right.
Yes. Yep.
Okay. And what kind of like do you have to play around a lot? How robust is it? Like if there's noise in the background and other things going on, what kind of filtering are you doing?
That's tough because on one hand, we want to make sure we hear the note accurately. We don't want to just be ignoring vocals and processing instruments or something like that. So we wanted to leave it fairly open. But it does kind of pick up on some excess noise. Our thought was when you're actually using this, when you're training, you'll be in a quiet room with you and just your music. So there isn't very much distraction. But if you're sitting there on a subway or something and singing into your phone, it's not going to very accurately be able to tell you what you're singing. On purpose, because we wanted to make sure that it covered all assets or all corners of musicianship, I guess.
Mm-hmm.
Cool. Just one other thing I wanted to throw out there was that it might be more interesting if you could somehow make it fun, or like in like new tech terms, make it addictive. I don't know exactly what that solution is, but like one thing that's kind of effective in the education space is the spaced repetition. So if you can kind of get people to come back and practice or whatnot to get better at it, I don't know. Just throwing that out as a suggestion.
We did one of our stretch objectives, and will be probably our objective after graduation, is making it sort of similar to Duolingo, where you have like an account and like we keep track of all your stats and like you can see your progress over time. So kind of like gamifying it, I guess, is kind of some steps we talked about to come.
Cool. Question, have you both studied or looked into the app Perfect Ear at all?
I'm not.
Okay, that's actually something that does this, but for, actually it pretty much is doing what you guys are trying to accomplish here. So I would definitely look into that and study into that and see, what things that they're doing that are working and, how you can translate it into your own. It's an app that's, I think, a handful of friends and vocalists have been using to kind of get that whole ear training thing going. Cool. I don't really have that much crazy feedback because, again, once you get your eyes on Perfect Ear and you get to try it out, you'll see, what opportunities for growth are there. But also, I have other things that I would consider I would want to see as a musician in something like this. So like you guys did say that you were going to add the opportunity to have a dictation of melodies, which I think is awesome. Like Perfect Ear doesn't do that. It's just, intervals and all that kind of stuff.
Mm-hmm.
But there's also the opportunity to kind of overlap with music theory. So like if I said, hey, I want to hear me sing a B flat diminished 7 chord or something like that, and I'll just give a student a B flat and then have the student match the pitches after that. Like that's an opportunity for them to know both just what the chord sounds like and how to dictate it, but also understand in theory, like I need to be thinking about these intervals going forward.
Right.
So I think that's also an opportunity, if you haven't thought of that already, to go ahead and explore that, because again, I don't think Perfect Ear does that.
Mm-hmm.
I think it's something that, musicians need to go more into, because even if you're, sing all the right notes, but don't know what those notes are translating to in the theoretical standpoint, it's kind of a not a full win. So it's definitely an opportunity, and I think you guys have an edge on that to go about that route.
Right.
Cool. Yeah, I like that. I think that's an awesome idea. Thank you very much for bringing that up. Perfect Ear. I think we should look into that.
Definitely.
Jack, that's awesome.
Yeah.
Cool. Thank you guys so much.
Thanks, guys.
All right. Well, thank you. We'll turn this over to Damien.
Cool.
Let's see here. All right. You see that all right?
Yep.
Hear me all right? Cool. All right. So my name is Damien Howard. My project is called Discover Music, and I'd just like to thank you all for tuning in so late to look at our projects. My elevator pitch for my project is that Discover Music is a web-based application that is designed to help users discover new genres of music based on their unique personality traits, those traits being openness, consciousness, extroversion, agreeableness, and neuroticism. The questions I initially started out with when thinking of what I wanted to do with my capstone is like, what is a music genre? Why does it matter? What separates one genre from another? And why do people like and dislike different genres? And were very broad things, and it was hard to come up with a project, but it got me researching. I found this website called Every Noise at Once, and basically what you're seeing here is every single genre tag that is listed on Spotify. And as you can see, there is a lot of content on here, and you are not going to hear 80% of these genres in your lifetime. And I think that's really sad. So I wanted to make something that like just gave people new genres to listen to. So what I did was I researched how people were already finding music, and I found that the biggest three things were in algorithms were similarity. These are things like Spotify and YouTube, which recommend users music that is similar to what they already listen to, as well as what is most popular. There's things like GNUsic, which will take in 3 bands and then returns a band that is similar to those 3. And then there's one called Stereo Mood, which will give you a playlist that is like dinner party or late night walk or something like that. But when I was trying to find like how to find new music genres, the options were like soul searching, try random genres, take friend recommendations, and I noticed that there was just no real way to like find new music genres. The biggest problem with all of them that I had was this word similarity. They were all showing you music that was similar to what you're already listening to, which of course isn't bad. They work great. You find new music that you like all the time because of these similar algorithms. But it helped me develop my secondary question that led to my project: to what extent do music genres affect people's personality and behavior? This was my case study in Capstone 1, and I found this data from the CEURWS scientific conference, and it shows the Bone-Ferrari correlations for music genres to the personality types based on age range. And all of these bold-faced numbers here are the ones where there's like a strong connection, where there's definitely something there. And I had a psychology mentor look at it, and she said that it was definitely something that was worth exploring. So I started doing some prototyping. The original plan for the project was for the user to have a profile where they would have like 50 personality questions that they would answer initially, and they would be able to come back daily for like a new playlist every day. They'd be able to like and dislike the songs, which would affect the algorithm, and they'd be able to link their Spotify account and all of that. My first working prototype ended up looking like this. This was built in React and used the Last.fm API to display music genres based on like different ifs and elses that I was just randomly trying. And eventually it got developed into this. This is what the final product is looking like at the moment. So basically, upon loading up the web page, the user answers these 5 randomized questions from a database of 200 questions from the NeoPy3 personality database. They will give their age and calculate, and they will be given a playlist of 10 songs, where if they click on the artist name, they will be taken to the Last.fm website where they will be able to listen to the song, or they can listen to the song on YouTube on the webpage. The technologies I was using, originally I had planned on using React, SQL, and the Spotify API to do what I was describing with my first prototype. However, the Spotify API ended up being very non-friendly to use due to its user authentication features. It just was not something that was possible on the Colorado servers at all, so I had to do a lot of testing and wasted a lot of time with it. So I reached a break point in the middle of the semester where I realized I needed to switch some stuff up. So I switched to jQuery and Last.fm, which has a lot less genres, but it was still able to do the general idea of what I wanted to do. And it also matched the data set that I had originally had for my case study. But that didn't really satisfy me enough. I knew that that wasn't going to be a challenge for me. So I also added in the YouTube API, and it was an interesting experience to get the 2 APIs talking to each other. And I feel like I was still able to challenge my coding abilities despite having adversity in the first half of the semester. And while the site isn't the prettiest, I think the code itself is pretty well written. It's here's some examples of what I have. On the left side is my JavaScript object, which holds just all of the data, the 200 questions, all of the different potential results for each personality type. Over here on the top right is the responsiveness. I spent a lot of time making sure that the site was responsive. If there were any barriers, or any errors that were reached, such as not answering all of the questions, if the YouTube API had reached its daily quota, just all of these different errors, making sure that everything was as responsive as possible. I just made sure that was my big thing, was that it was responsive. Here on the bottom is a little bit of the algorithmic work. There's a lot of randomness involved, but I think that's okay. Like, randomness is a good thing, especially in music. And it's more like just trying to find a new way to discover new genres of music more effectively. I think I did a good job of doing that, and I'd love to continue developing it in the future and adding in more and more of those features that I talked about with my first prototype. So yeah, that was my project, and I'll open up to questions. That's a little fast.
All right, I guess that means I go first. Well, thank you. Cool presentation, cool project. I like this idea that you're kind of going against the similarity vector or whatnot. I'm a kind of a radio person. I love the radio because it's someone else selecting for you. And you kind of get these uncertain and unexpected surprises in the best sense. Not when you're listening to like the pop channels or whatnot, but anyway, I like this idea. Like, the questions to me were like the coolest part of this project. Like, it almost felt like a poetry, the way you're asking people these sort of unusual questions, and then you end up with like a selection of music because of it. I was wondering if you could just talk a little bit about that, what kind of ideas you explored.
So I was talking a lot with my psychology mentor about this, because I have no like background in psychology. I've taken like one psychology class in the past, and she was the one that recommended this NeoPi database to me. It's like the most effective at determining the 5 personality types, and I figured that those 5 personality types would be like the best at keeping the code robust, but also like giving enough options. So there's like different avenues for the user to go down to. So if they keep reusing the website, they're always going to be getting something new. And that's what I wanted, is that it was reusable as many times as they wanted to get new genres.
Yeah, cool. The only other thought I had was that maybe instead of exploring these random processes, if you explored like stochastic processes, which are like randomness within like a range, and it could be an interesting way to keep on similar avenues, but like do like random walks within certain ranges. Just throwing that out there.
I think that is kind of what it was doing. I showed that little snippet at the end of the object I had. It had like I should have explained that a little better. I could share my screen again. Let's see. Which one was it? Here we go. Yeah, this object here, it has this like young high, young mid, young low, and the randomness is all like kept inside of these predefined little boxes. I would have liked to have some more overlap between the two, and some of them do. Like R&B, as you see in this one, appears in both old mid and old low, and that was me just like interpreting the data set. I spent a lot of time with that data set, just interpreting it and trying to spread it out evenly over this object that I was building.
So when you're looking into something like this, did you kind of factor in like crossover between them? So like if somebody's like their answers are leading towards a lot of R&B, was there like a subset of that was saying, hey, but they should also get some electronic? Like, is that also being put into their playlists, or is it just going to be like for lack of a better analogy, that week that you get on Spotify when all they give you is metal and you'd never listen to metal music or whatever, something like that. Like, is it going to be like that, or is it, you know, kind of trying to lean towards a certain direction?
Yeah, in its current state, it just returns one genre.
Okay.
But I would like in the future like to have like full curated playlists with profiles. But I need to spend a lot more time with SQL and Spotify API. But,
For sure. I mean, I feel like with what you've got going, you know, you have the opportunity to actually like start melding some of that, because some of those personality questions, I don't know any of the data that you've got on it, but I assume that some of those personalities have crossover between the two.
yeah,
And
sure.
I would encourage also like the opportunity to, if it's not already possible, to kind of like or dislike a selection or recommendation, because that could
definitely
also like, you know, influence the next direction in which something will happen genre-wise.
Yeah, that was definitely the feature that I wanted to build next, but I spent so much time on the Spotify API that I just didn't get around to it.
Nice. It's definitely really cool. I'm a huge like personality trait nerd. So I'd be very curious like what the Myers-Briggs equivalent to each genre ends up being, if that's like a thing.
Oh yeah, that would be an interesting avenue too. I would like to like build full profiles with more than just the big 5 personality types. I think that'd be cool. In the biggest idea I have, it would be like many different ways to find new genres, not just personality. Like, what hobbies do you have? Where do you spend your time? What times are you awake during the day? Like all of those types of things I would like to consider. But this was just like a good capstone starting point for me.
Oh yeah, this is like diving between sociology and psychology at the same time, so I love it.
All right, thank you. Okay, so Matt, you are the last presenter of our 12-hour marathon thesis presentation. So take us home.
Alrighty, I hopefully won't take too long. Can you guys hear me okay? Cool. All right. So for my capstone, I'm Matt Sexton, by the way. For my capstone, I made the harmonic hoodie, which is a wearable instrument designed for creating music anywhere you go. Oh, shoot. Let me move this. Okay. All right. So the whole purpose of my project was to creatively combine wearable technology with music creation and build something that stands on its own and needs no other music accompaniment. So my intended audience is for creators and music lovers of any background or musical experience who want to create and play music. So kind of the whole intention is for it to be a personal and intimate device for music creation rather than live performance. So while you could plug it into an amp or a speaker, it's really meant to be used with headphones. So here are just some of the precedent research I did that inspired me. First one, drum pants, as the name might suggest. Obviously, it turns your legs into a percussive instrument using sensors. And then showpiece is more of a art feature than music, but it uses sensors located on a jacket to play sounds. So taking that for inspiration, this is what the final design of my capstone looks like. There's 16 different sensors located easily accessible around the jacket. And as you can see, it's labeled. Each sensor does something different based upon where it is and the color. So some of the features are pause and resume. You can change the volume. You can switch synths. And then you can play loops and drums and bass tracks. And then kind of the main feature of the jacket is with these synth notes here at the bottom. It'll play all the 7 notes in a key and then the next octave of the first note. And the reason I chose this design is just so that truly anyone, regardless of musical experience, can throw on the jacket and noodle around with it
and it won't necessarily sound bad because it'll match the key of the preset loop track. So here's just a quick demo of just the functionality of the jacket. Cool. So how it works, basically, the brains of the whole jacket are with this wave trigger PCB here at the bottom left, that red circuit board. It's from SparkFun. It's a really cool product. It's capable of playing polyphonic CD quality audio, and it has 16 programmable trigger inputs, which is what the sensors are soldered into. It also has an onboard headphone jack, which is really nice. And all of the code and all of the sounds just load onto this micro SD card that's on it. You can also see I'm using an Arduino Uno, which I was originally going to use for more, but as it is now, it's just basically a voltage regulator and power for the sensors, as each sensor needs 3.3 volts and the wave trigger itself needs 5 volts. And then you can see on the right here, the actual sensors I'm using. They're capacitive touch sensors, also from SparkFun. So they work just by sensing the conductivity in your skin, and they send a signal that way. So challenges and process I went through. In the top left here, those were my original sensors. They're piezo contact sensors. And I had a ton of issues with these. They work by force rather than touch. And so I was getting a lot of latent signal and a lot of unresponsiveness with them. So I quickly pivoted to the capacitive touch sensors, which made a big difference. And then just kind of an unforeseen issue I ran into is just with the capacitive touch sensors, they use 3 wires, a power, a ground, and a signal wire. And just as you can see in this middle picture, only half of the sensors are implemented, but it just ended up being a ton of wire. And not having access to the ITLL or a sewing machine, I couldn't really go forth with my original design of just sewing fabric over the wires, or I didn't have any conductive wiring or like conductive thread or anything. So I kind of had to improvise just with the fabric and duct tape. So the inside of the jacket, as you can see on the far right, isn't quite as pretty as I originally wanted it to be, but functionally it works really well still, and you still have easy access to the headphone jack and to the micro USB or micro SD card. And then I just wanted to show kind of just a demo video of kind of the capability of the jacket and what you can do with it. Cool. So that's it. Thank you, guys.
All right, thank you. Cool project. I also want to see your drum pants and your other instruments as well. I love this idea of thinking about the human body as this expressive machine. You know, and we have this ability to move and act in this space, but damn, they don't make sound. Anyway, I like this thing. I was wondering if you could talk about the actuators, so why you were using mostly hands instead of saying arm movements or something like that, and if you could talk a little bit about the buttons you were making, if there's some way to make it more I don't know, squishy, droney, have more than just like a touch after touch kind of thing?
Yeah, I mean, so the original, my original intention was so that you could kind of be walking around just anywhere you go and still be playing this. So if I had incorporated any like crazy movements, I feel like it wouldn't have worked as well for just everyday, like casual use. Did that kind of answer your question?
Yeah. Just seeing the project from before, from the Not Impossible labs, I'm like, now I want like the Eye of the Tiger, where I go bump, 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 something like that. I don't know, dumb idea, but I'm throwing it out there. Anyway, I like the project. I like that you kind of really made it an extra effort to piece it together into a jacket. And I'll just pass it on to the other reviewer.
Thank you.
Cool. Awesome. I like this idea. I love tactile instruments. There's like a hand piano thing that you can use where you have a glove and it makes notes and all that kind of stuff. And I don't think I've seen many that have like, a full body experience with that. So cool, good work on that. But my questions kind of rely on I don't want to say the ability to make music with it, but like, hitting 8 notes is one thing, but like how you hit them can make a difference in how the music happens. So are you kind of considering like velocity and, the dynamic in which you can play these things? Or is it just right now a solid set of dynamics and such?
It'd be really cool to mess around with the dynamics, just based upon how hard you press on it. I don't think the sensors I'm using are capable of that. They do have the ability to, like, as long as your finger is touching the sensor, it'll play the sound.
Great.
And you have, expression there. But yeah, no, you can't mess with the dynamics.
Okay. And how long are the loops generally lasting for this? Like, is it an 8-measure loop? Is it something that can be changed and adjusted?
Yeah, you could change it after the fact. I think I have like 3 loops loaded on right now. I think they're all 8-bar loops.
Cool.
Yeah.
And you mentioned that there was kind of a way to put it into like headphones and an amplifier, but like, is this something you can plug into a computer and basically make like a MIDI recorder out of? Is that a direction you're trying to go for, or?
Could be, yeah. It outputs to a headphone or to an aux cord. So yeah, you could do that.
Gotcha. Cool. I think the last question I really had was, is there an ability to record off of this? Because I know the big deal, like if I'm walking down the street and I have like this melody in my head,
right?
I would generally just take my phone out and like sing it into my phone, right? But if I have this jacket on, can I like hit a button and just like play that thing on my belly while I'm walking, and then like pull that on the computer and like Pro Tools later or something like that?
That was a feature I really wanted, but it's just kind of looping with the specific circuit board I picked just proved a little difficult. So that'd be definitely moving forward a next step.
Nice. Excellent idea, though. It's pretty solid work.
Thank you.
Great job.
All right, so that concludes the entire day of projects. But for this session, first of all, a round of applause to the 4 of you for presenting. Good job, excellent work.
Nice job.
Sorry, I got 4. It's 4 projects. It's not 4 people, though, is it? 6.
5 people.
5, yeah. And then also a big thanks to our reviewers for coming, Emmanuel and August. Thank you so much for your feedback for our students.
Thanks for having us.
Yeah, thank you. My pleasure.
And that concludes the whole day. So goodbye to everybody. Oh, I got something for August real quick. Let's see if this works.
Tell me you're gonna play Eye of the Tiger.